Aluminum wiring is permitted for branch circuits, feeders, and services in commercial and industrial occupancies, including assembly occupancies according to National Electrical Code Article 310.15b3. However, it must meet specific conditions. Firstly, the ampacity must be based on Table 310.16, which specifies a lower ampacity for aluminum conductors compared to copper conductors. Secondly, the wiring must be installed in accordance with Article 300.3, which requires conduit for concealed wiring in walls. There is an exception: aluminum wiring smaller than 8 American wire gauge is permitted to be installed without conduit in raceways or enclosures where all conductors are insulated for the circuit voltage. This exception is typically used for branch circuit wiring. Based on the current National Electrical Code requirements, aluminum wiring is allowed in an ampacity assembly occupancy provided that it meets the specific conditions outlined above. It is required to be run in conduit for concealed wiring in walls, except for aluminum wiring smaller than 8 American wire gauge installed in raceways or enclosures. Relevant National Electrical Code sections include Article 310.15b3, which covers uses permitted for aluminum, copper-clad aluminum, or copper-clad steel conductors. Article 300.3 covers wiring methods. Table 310.16 details ampacities of insulated aluminum conductors. When using aluminum conductors, it's essential to consult Table 310.16 to determine the appropriate ampacity based on the conductor size, insulation type, and installation conditions. The ampacity of an aluminum conductor is generally lower than that of a copper conductor of the same size. This means that a larger size aluminum conductor may be required to carry the same amount of current as a smaller size copper conductor. Proper termination of aluminum conductors is crucial to prevent overheating and failures. Use connectors and terminals that are specifically listed and labeled for use with aluminum conductors. These connectors are designed to accommodate the expansion and contraction of aluminum due to temperature changes. When connecting aluminum conductors to copper conductors, use listed and labeled transition connectors that are designed for this purpose. These connectors prevent galvanic corrosion, which can occur when dissimilar metals are in contact. Always follow the manufacturer's instructions when installing connectors and terminals for aluminum conductors. Over-tightening or under-tightening can lead to connection failures. Inspect aluminum wiring connections periodically to ensure that they are still tight and in good condition. Look for signs of corrosion, overheating, or loose connections. If any problems are found, correct them immediately. When working with aluminum wiring, it's important to understand the different types of aluminum alloys that are used for electrical conductors. Older aluminum wiring, such as Amanus 1350 alloy, is more prone to expansion and contraction than newer alloys. If you are working with older aluminum wiring, it's especially important to use connectors and terminals that are designed for use with that type of wiring. The National Electrical Code requires that aluminum conductors be identified by the marking AL on the conductor insulation or jacket. This marking indicates that the conductor is made of aluminum. The National Electrical Code also requires that aluminum conductors be sized according to their ampacity, as determined by Table 310.16. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. When installing aluminum wiring in conduit, it's important to choose the correct type and size of conduit. The conduit must be large enough to accommodate the conductors and any necessary fittings. The conduit must also be made of a material that is compatible with aluminum. Aluminum conduit is often used for aluminum wiring installations. When installing aluminum wiring in walls, it's important to follow the requirements of Article 300.3 of the National Electrical Code. This article requires that concealed wiring be installed in conduit or other approved raceway. The purpose of this requirement is to protect the wiring from physical damage and to prevent the spread of fire. When installing aluminum wiring in raceways or enclosures, it's important to ensure that the raceways and enclosures are properly grounded. Grounding helps to protect against electrical shock and to prevent the buildup of static electricity. The National Electrical Code provides specific requirements for grounding electrical systems. When working with aluminum wiring, it's important to be aware of the potential hazards. Aluminum wiring can be more prone to overheating and failures than copper wiring. It's important to follow all safety precautions when working with aluminum wiring. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with aluminum wiring, it's best to hire a qualified electrician. A qualified electrician has the knowledge and experience to safely install and maintain aluminum wiring systems. The National Electrical Code is a comprehensive set of standards for electrical installations. It is important to consult the National Electrical Code before working on any electrical wiring project. The National Electrical Code is updated every 3 years. It is important to use the latest edition of the National Electrical Code. The National Electrical Code is available from the National Fire Protection Association. In addition to the National Electrical Code, there may be local electrical codes that apply to your area. It is important to consult with your local building department to determine which electrical codes apply to your project. Aluminum wiring has been used in residential, commercial, and industrial buildings for many years. However, it is important to understand the potential hazards of aluminum wiring and to follow all safety precautions when working with it. With proper installation and maintenance, aluminum wiring can provide safe and reliable electrical service. It's crucial to emphasize the importance of using appropriate tools and techniques when working with aluminum wiring. Standard wire strippers may nick or damage the aluminum conductor, leading to potential failure points. Use wire strippers specifically designed for aluminum wiring, which have a smoother cutting action. Torque screwdrivers or torque wrenches are essential for tightening connections to the manufacturer's specified torque. Over-tightening can damage the connector, while under-tightening can lead to loose connections and overheating. Regularly inspect aluminum wiring connections, especially in older installations. Look for signs of corrosion, discoloration, or loose connections. Thermal imaging can be a valuable tool for identifying hotspots in electrical panels and wiring, which can indicate loose or corroded connections. If you find any issues, consult with a qualified electrician to make the necessary repairs. Consider the environment where the aluminum wiring is installed. In damp or corrosive environments, special precautions may be necessary to protect the wiring from corrosion. Use corrosion-resistant connectors and enclosures. Apply a corrosion inhibitor to the aluminum conductors and connections. In areas with high humidity, consider using a sealant around the connections to prevent moisture from entering. When replacing or upgrading existing aluminum wiring, consider the overall electrical system. Ensure that the panel board, circuit breakers, and other components are properly rated for the load. Upgrade the grounding system if necessary to meet current code requirements. In some cases, it may be advisable to replace the aluminum wiring entirely with copper wiring. This is a more expensive option, but it can provide a more reliable and safer electrical system. When making any changes to an electrical system, it's important to obtain the necessary permits from your local building department. This ensures that the work is done in accordance with the applicable codes and regulations. A qualified electrical inspector will review the plans and inspect the work to ensure that it meets the required standards. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely install and maintain electrical systems. They can also help you to identify and correct any potential hazards. In summary, while aluminum wiring is permitted under specific conditions outlined in the National Electrical Code, understanding these conditions and adhering to proper installation and maintenance practices are paramount for ensuring electrical safety and reliability. Remember to consult the latest edition of the National Electrical Code and local codes for the most up-to-date requirements. Always prioritize safety and seek the assistance of a qualified electrician when in doubt. Furthermore, it is important to understand the specific requirements for assembly occupancies as they often have stricter regulations due to the higher risk associated with large gatherings of people. These requirements may include additional fire protection measures, emergency lighting systems, and exit signage. When designing or installing electrical systems in assembly occupancies, it is essential to consider these additional requirements and to ensure that the system meets all applicable codes and regulations. Consider also the specific use of the assembly occupancy. For example, a theatre may have different electrical requirements than a restaurant or a church. The electrical system must be designed to accommodate the specific needs of the occupancy, including lighting, sound systems, and other electrical equipment. In addition to the National Electrical Code, there may be other codes and standards that apply to electrical installations in assembly occupancies. These may include the International Building Code, the International Fire Code, and the Americans with Disabilities Act. It is important to consult with your local building department to determine which codes and standards apply to your project. Remember that the goal of electrical codes and standards is to protect people and property from electrical hazards. By following these codes and standards, you can help to ensure that your electrical system is safe and reliable. And always, when in doubt, consult a qualified electrician. They can provide expert advice and ensure that your electrical system meets all applicable requirements. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any decisions about your electrical system. Stay safe and ensure your electrical installations are code compliant.